Welcome to solverfy.
This is the answer to Chapter 16, problem number 11 from the Smith Organic Chemistry textbook. And this problem says, using hybridization, predict how the bond length of the carbon-carbon sigma bond in butane should compare with the carbon-carbon sigma bonds in ethane and then in butadiene. And so I've drawn those three molecules here. Butane, or I guess it would be dibutane to the left, and then 1,3-butadiene in the middle, and then ethane to the right. And so basically, since this is telling us use hybridization, obviously we need to consider the hybridization of the carbons involved in these sigma bonds. And hopefully you remember from earlier in the book, percent S character. So a bond with a higher percent S character is going to have a smaller orbitals. And since it's made of smaller orbitals, it's going to be a shorter bond. And so looking at the first molecule here, we need to look at the two carbons that are involved in the bond. And so we're talking about this carbon and this carbon, and they're both participating in a triple bond. And so they're both going to be sp hybridized. And so we're talking about an sp hybridized carbon bound to an sp hybridized carbon. And so there's going to be 50% S character in this bond. So 50% S. And so that's going to be quite a short bond. But in order to rank them, we should probably decide what S character each of them will have and then rank them accordingly. So looking at the next molecule, we're considering these two carbons, and they are each sp2 hybridized. So we have a C sp2 bound to a C sp2. And so 1/3 of the orbital is S. And so this is going to be 33% S character. And so this will be a longer bond than the first molecule. However, when we look at the third molecule here, the ethane, we're talking about two sp3 carbons bound together. So sp3 bound to a C sp3. And so there's only going to be 25% S character here. And so what that means is that we can now rank these in order. So this will be the shortest because it has the most S character. And the single bond in ethane will be the longest because it has the least S character. And that's going to put this middle molecule right in the middle. So intermediate. All right, and so that's how to solve this problem. We're specifically told to consider hybridization. And so we need to look at the hybridization of the carbons that are participating in the single bonds that we're looking at, and then use those hybridizations to determine what percent S character these bonds have. And then once we know that, we can rank them from shortest to longest. And that's the answer to Chapter 16.